गुड मॉर्निंग फ्रेंड्स। आज हम देखेंगे कॉम्प्लेक्सोमेट्रिक टाइट्रेशन फ्रॉम फार्मास्यूटिकल इनऑर्गेनिक केमिस्ट्री, जो कि एज पर पीसीएस नॉर्म्स, पीसीएस सिलेबस फार्म डी एंड बी फार्म के लिए भी एप्लीकेबल है। सो हम ये चैप्टर देखेंगे आज। सो जिन लोगों ने भी सब्सक्राइब नहीं किया है चैनल, प्लीज़ वो सब्सक्राइब कीजिए सो फर्दर नोटिफिकेशंस के लिए। तो हम आज देखेंगे कॉम्प्लेक्सोमेट्रिक टाइट्रेशन, व्हाट इज मीन बाय कॉम्प्लेक्सोमेट्रिक टाइट्रेशन, देन टाइप्स ऑफ कॉम्प्लेक्सोमेट्रिक टाइट्रेशंस, then indicators which are used in this titration. One by one we will see that. So first of all, see, these are the contents we are see, will see classification of complexometric titration, then metal ions indicators, masking and demasking agents, and the estimations part. So first of all we'll see the complexometry. What is exactly complexometric titration? Simple, आप ध्यान रखिए, यहाँ पे अगर हम मेटल आयंस का टाइट्रेशन चेक करें, डिटर्मिनेशन ऑफ द मेटल आयंस is called as the complexometric titration. The for simple definition is that it is the determination of metal ions by using the titration method is called as complexometric titration. Simple. Okay. So it is a form of volumetric analysis in which the formation of colored complex is used to identify the end point of the titration. Colored complex will be formed which is used for the identification of the end point of the titration. Complex titrations are particularly useful for determination of the mixture of the different metal ions in a solutions. Okay, it is identify the different mixture of the different metal ions in a solution is called as complexometric titration. आपको यही ध्यान रखना है, complexometric जहाँ पे भी वर्ड हमें दिखता है वहाँ पे we can say that it is identify the mixture of the different types of ions, metal ions. Okay, so this is the meaning of the complexometric titration. We will go towards the principle. What is the exactly principle of the complexometric titration? Principle, the main principle is the reaction between the ligands and the metal ions to form a complex. It is the main principle between the reaction. Two parts is that the ligands and metal ions. The reaction between the ligands, also the metal ions, to form the complex is called as see, this is the principle. See, this is the metal ions and these are the ligands. Okay, so this is they will form the complex by the reaction between the ligands and metals. It is the principle of the complexometric titration. The metal ions acts as a Lewis acid and ligands acts as a Lewis base. We can consider that Lewis acid is a metals and Lewis base is a ligands, which is a complexometric agents. Okay, this is the examples given that in for a complex principle of the complexometric titration. That is the silver and the cyanides. Okay, this is the simple example as a metal, also in the ligands it gives the silver cyanide. So this is the simple principle of the complexometric agents. That is the metal ions plus chealating agent, that are the complexometric agents. It will give the metal ligands complex. Okay, according to the principle of the complexometric titration. Then हमें एक क्वेश्चन आ सकता है कि व्हाट इज मीन बाय लिगेंड्स. अभी लिगेंड क्या है? सो लिगेंड इज अ स्पेसिस विच डोनेट्स द लोन पेयर ऑफ इलेक्ट्रॉन्स. ऐसा है कि वो डोनेट कर सकता है लोन पेयर ऑफ इलेक्ट्रॉन्स. सी द लोन पेयर ऑफ इलेक्ट्रॉन्स ऑफ द एंड टू फॉर्म द कोऑर्डिनेट लिंकेज विद द मेटल आयंस. ओके, एक तो डोनेट करता है लोन पेयर ऑफ इलेक्ट्रॉन्स एंड फॉर्मेशन क्या करता है? इट्स अ लिंकेज कोऑर्डिनेशन विद द मेटल आयंस. And there are further classification of the ligands. There are mainly three types of the ligands classifications. Just आपको ध्यान रखना है. It may be asking two marks question. What is meaning? Define the ligands and classify it. Okay, आ सकता है maybe. So this is the question for that. The classification of the ligand. It is a unidentate first class, then bidentate and multidentate. See, यहाँ पे हमें पता चलता है unidentate. Okay, it's a singular. Bidentate is a bi, that is the two sides, and multi means more than two. Unidentate if a single site is present in a ligand to form the complex. Okay, जैसे कि हमने देखा it's donating the lone pair of electrons, so there only a single site for the donating the lone pair of electrons is called as the unident. An example is the cyanide ions. Cyanide ion is the example of unidentate. Bidentate, two sites are present in the ligands. Example glycine and oxalic acid. ये आप ध्यान रखो, ठीक है. यूनिडेंटेट आपको दिया रहता है, तो उसके बाद हमने साइनाइड अपना एग्जांपल है. देन बायोडेंटेट इज द ग्लासिन और ऑक्सैलिक एसिड इज द एग्जांपल फॉर दैट. टू साइड्स प्रेजेंट इन बायोडेंटेट for the shifting of the electrons. Then multidentate, it's more than two sites are present in the presents. When more than two or three sites are present for the lone pair donating the lone pair of electrons is called as a multidentate. An example is the EDTA. Okay, this is the simple the meaning of the ligands and the classification of that. Okay, next we will see what is meaning of the chelating agents. Next question, what is meaning of chelating agent? It is an organic molecule. See, simple, it is organic molecule containing two or more donor groups. Chelating agents have two or more groups, okay, donors groups, which combines with the metal to form the complex having the ring structure. See, यहाँ पे 2 और 3 donors group रहते हैं, which is reacted with the metals to form the complex ring structure. See, ये आपको ध्यान रखना है, ring structure यहाँ पे form होता है due to the chelating agents and due to the two or more donor groups present in that two or more groups will react with the metal and it forms the complex having the ring structure. Okay, so this is called as we can say that the chelating agent. Next, they are also known as the chelants. We can tell them that is a chelants, then chelators or sequestering agents also. Okay. Then the most effective chelating groups in ligands are the amino and carboxylate ions. See, these are the two groups. We can say that amino and carboxylate ions also. This is the example for that. These are the chelating agents. Dimethyl glycine, dimethyl, CH3. This is the two methyl group is there, so that you can say that dimethyl. This is the glycine and salicylofloxacin. Okay, these are the two chelating agents we are using as a chelating agents. Next we will go towards the classification. क्या है? What is the classification of the complexometric agents? Okay, so first of all, see, there are basically it is differently mentioned in our various books and other things. Okay, by the references. For this we can say that there are 5 classes are there. Okay, the first is the direct titration, then back titration, then replacement titration, then alchemetric titration, and last is the indirect titration. These are the 5 classes are there. So first of all, we'll see the direct titration. It is the simplest and the most convenient method. Okay, see, simple है, convenient है. Then standard chelating agent solution is added to the metal ions and solution until the end point is detected. क्या करते हैं यहाँ पे? Standard chelating agent solutions is added to the metal ions for the end point detection. In this metal ions is added to the suitable buffer solution and appropriate indicators solutions, and resulting the solution is titrated with the EDTA solution. Example वो कौन सा है इसमें direct titration में? कौन सा है? Zinc है, nickel है, copper है, can be determined by using the direct titration. But see, these are the metals we can determine by this using the direct titration. Example, calcium gluconate injection is acid. हम ऐसे क्यों करते हैं? So for the identify the purity of the drugs. Okay, acid for the determination of the calcium chloride. This is the direct titration. Okay, तो यहाँ पे हमें disadvantages भी मिलेंगे इसके. What are the disadvantages? It is a time consuming method. यहाँ पे time consuming method है for the identification of the endpoint. Of the time is more for the complex formation also, and also interference of the other ions are also. Okay, हम एक ions identify करने की जगह पे वहाँ पे interference of other ions also can possible. So these are the two disadvantages of this method, direct method. आपको simple ध्यान रखना है. It is a simple and convenient method. The chelating agents we can add in the metal ions to form the complex and endpoints detection. Which are the metals we can identify by this using this method? The so many zincs and nickels and all things. So we can identify these from this method. And the example is the calcium gluconate injection is assayed for the determining calcium chloride. And disadvantages, it is a time consuming method. Also it can form the other reacted other metal ions. Okay, this is the simple way to understand the direct titration. Second is the back titration. See, in this method, excess of complex agent is back titrated with the standard solution of the second metal ions. यहाँ पे हमें क्या करना है? Excessing of the complexing agents is titrated with the standard solution of the metal ions. In these metals method, excess of EDTA solution is added. क्योंकि हमें बोला है कि ज़्यादा हमें यहाँ पे excess quantity में लगेगा. So sample solution and pH is adjusted also. Then the resulting solution is back titrated with the appropriate titrate. See, these are the we can say that the standard metal ions we are using for the zinc chloride, zinc sulfur, magnesium chloride, magnesium sulfate. Okay, these are the standard metal solutions we are using for this titration, and these are the metals we can identify or determine by using the back titration method. Okay, so aluminum, copper, manganese, etc., nickels. Okay, we can say that these are the metals we can identify or determining by using this. Okay, so and the example is the manganese determined and zinc oxide determination, etc. This is the back titration, second class of the complexometric titration. Third is the replacement titration. See, the name indicates that the replacement of the metals. Okay, simple है, replacement एक से दूसरा replace हो सकता है. See, by the name it's indicate that the replacement of the metal ions with other metal ions. एक metal ion दूसरे metal ion के साथ replace हो सकता है. So you can say that replacement titration in this method, but it does not give the sharp endpoint. लेकिन इस मेथड का एक प्रॉब्लम है कि ये शार्प एंड पॉइंट नहीं मिलेगा. ठीक है. सो दिस इज द वन ऑफ द डिसएडवांटेजेस ऑफ दिस मेथड, रिप्लेसमेंट मेथड. दिस मेथड इज यूजफुल फॉर द डिटर्मिनेशन ऑफ कैल्शियम आयंस. ओके, ये हमें ध्यान रखना है ये भी कि अभी कॉम्प्लेक्सोमेट्रिक टाइट्रेशन इट इज़ टोटली डिपेंड्स ऑन द मेटल आयंस. ओके, आइडेंटिफाई द मेटल आयंस. तो हमें एक ही देखना है कि मेटल आयंस कौन कौन से किसको एप्लीकेबल है. तो ये हमें कॉमन मेटल आयंस का लिस्ट निकालना है कि these are the common metal ions we are using for the determination of the complexometric titration. So according to the classification, we say that the classify the different metal ions for the class. Okay, एक पेज पे आपको लिखना है और वो पेज हमको पढ़ना है बस. तो आपको आइडेंटिफाई हो जाएगा कि कौन कौन से कैल्शियम मेटल आयंस we are using for the different class. See, this is the example for the same replacement. See, here manganese is there and magnesium is there. So manganese reacted with the magnesium EDTA. Then according to replacement titration definition, we can say that the one metal ions replaced by the other metal ions. So here manganese is replaced by the magnesium, and it will disform this is the reaction. Manganese replaced by the manganese. And manganese attached to the EDTA, it will the manganese EDTA. So this is the replacement. Next is the alkylometric titration. This method is used to the principle of the liberation of the free H plus ions during the complexation. यहाँ पे क्या होता है? Free H plus ion liberation होता है. Okay. So H plus ions can be also determined by the instrument method. Next is the indirect titration. Here the proton from the complexometric agents are displayed by the heavy metals and titrated with the sodium alkali. Okay, यहाँ पे displaced by heavy metals and titrated with the sodium alkali. This method is useful for the analysis of, see, this is the sodium, potassium, silver, etc. See, the chlorine, bromine and fluorine. These are the indirect titration. So we seen that the 5 types of the classifications, okay, of the complexometric titration. यहाँ पे question आ सकता है, maybe 6 marks or 2 marks. Okay, so you have to prepare that accordingly. Next step, metal science indicators. What are the indicators we are using? There are 4 types of basic indicators we are using in a complexometric titration. That is arenochrome black tea, okay, mureoxide, xylonol orange, and pyridyl zonalphthol. That is the PAN, PAN, okay, short form. This definition of the already the indicators definition. It is a substance that changes the color. Okay, क्योंकि हमारा एंड पॉइंट इंडिकेटर के ऊपर ही डिपेंड है. इंडिकेटर एडिशन के बाद ही हमें we can get the changes in color and our end point color when it binds with the metal ion solution. Then if suppose we know the four different indicators, then what are the requirements of the indicators? The color must be sufficiently intense so that minimum amount of indicator can be used. कलर हमें यहाँ easily आना चाहिए और sufficient quantity में आना चाहिए, okay, of the indicators. Means then color contrast between the indicator metal and indicators complex should be readily observable. Okay, they easily identify the color contrast and observation. The metal indicators complex should possesses the sufficient stability होना चाहिए to ensure the sharp end point. Okay, stability stable होना चाहिए, क्योंकि क्या होता है जब भी हम टाइट्रेशन करते हैं उस टाइम पे एक दो ड्रॉप डाला फिर तुरंत हमें एंड पॉइंट दिखता है, लेकिन फिर भी हम शेक करते हैं तो वो एंड पॉइंट निकल जाता है. So there is a stability required for the color changes, and however it should be less stable than in the metal EDTA complex. Then next is the change in equilibrium from the metal indicator complex in metal EDTA complex should be sharp and rapid. ये sharp होना चाहिए, जो भी change है sharp रहना चाहिए और जल्दी आना चाहिए, that is the rapid. Color reactions of the indicator should be selective होना चाहिए. Then indicator must be very sensitive to the metal ions so that the color changes occurs at the near equivalence point. नियर इक्विवेलेंस पॉइंट ही अपना कलर चेंजेस होना चाहिए, नहीं तो बाद में और लेट नहीं होना चाहिए और पहले भी नहीं आना चाहिए. सो दैट कलर इक्विवेलेंस पॉइंट इज़ वेरी इंपॉर्टेंट पार्ट एज अ रिक्वायरमेंट बेसिस. देन इंडिकेटर मस्ट बी स्टेबल. ओके, टाइट्रेशन मीडिया में स्टेबल होना चाहिए. इंडिकेटर मस्ट बी स्टेबल ऑन द स्टोरेज ऑल्सो. ओके, स्टोरेज कंडीशन में भी एप्लीकेबल होना चाहिए. ओके, जैसे कि हम बहुत सारे प्रोडक्ट्स देखते हैं उसके ऊपर लिखा होता है कि इट शुड बी स्टोर इन कूल एंड ड्राई प्लेस. ओके, सो अकॉर्डिंग टू द स्टोरेज कंडीशन ऑफ द लैब और इंडिकेटर शुड बी सुटेबल फॉर द स्टोरेज कंडीशन. Then all above requirements must be fulfilled in the pH ranges. Different pH ranges we can tell that according to the pH ranges it should be a stable for that pH ranges. It should be commercial. Okay, easily available होना चाहिए मार्केट में, नहीं तो उसका रेट हाई है, ये है वो है. So commercially it will be available and allocate the purity of the samples 100% pure होना चाहिए. See, these are the different examples of the metal ions. That is already we discussed that Inorganic black tea it is used for the estimation of manganese. See, मैंने जैसे बोला था कि आपको different see there are different metal ions are there. Okay, so first of all you identify the common metal ions you are using for the these four indicators, and then afterwards after common metal ions, those are the different metal ions in that you can differentiate that. Okay, so first of all Inorganic black tea, it is used to estimate the manganese, zinc, manganese, okay, magnesium, cadmium, copper, etc., nickel, muroxide, also calcium. See, there are some identification, similar identification is there, so that according to these four indicators you can share that. Okay, then next concept is the masking and demasking agent. What is the masking agent? It is the reagent used in the chemical analysis. एक reagent है जो कि हम chemical analysis में use करते हैं, which reacts with the chemical species that may interfere the inner analysis. जो भी chemical species react होता है, जो भी interference होता है, उसके लिए masking agent हम use करते हैं. वो masking agent उसके साथ react होता है. Okay, so what are the examples of masking agent? Triethylamine. See, this is the triethylamine example of the masking agent. It is used as a masking agent for the ferric, aluminum. Okay, then next is the fluoride. Fluoride also one of the example of the masking agent. It is used as a masking of ferric and aluminum. Next is iodide. It is masking agent for the. Okay, see, these are the what is the example: triethylamine, fluorides and iodides. Okay, so next is the हमें पता चला मास्किंग एजेंट जो कि इंटरफेरेंस जो कर रहा है उसके लिए उसके साथ वो रिएक्ट होता है. ठीक है, नेक्स्ट है डी मास्किंग एजेंट. डी मास्किंग एजेंट क्या है? इज द टेक्निक रिलीजिंग द मास्क्ड स्पेसीज, रिलीजिंग द मास्क्ड स्पेसीज सो दैट इट इज़ फ्री टू रिएक्ट विद द प्रिंसिपल रिएजेंट. मास्क्ड स्पेसीज जो भी है उनको रिलीज करेगा सो दैट वी कैन रिएक्ट दैट फ्रीली टू द प्रिंसिपल रिएजेंट्स. इट्स कॉल्ड एज डी मास्किंग एजेंट. What are the example? That is formaldehyde and acetic acid is the best example of the demasking agents. What are the ideal requirement for the demasking agents? So it should be readily reacted with the precipitation. देखो हमारे जाके कुछ भी है तो हमारा लास्ट में पॉइंट आता है कि इट शुड बी रेडिली अवेलेबल विद द रिएक्टेड विद द प्रिसिपिटेशन. इट शुड बी फॉर्म अ स्टेबल कॉम्प्लेक्स ऑल्सो. ये दो तीन शब्द जो है ना वो हमें ध्यान रखना है. इट शुड बी रेडिली रिएक्टेड विद द प्रिसिपिटेशन, देन इट शुड बी स्टेबल, then it should be give the sharp end point, etc, etc. Okay, these are the basic requirements of the any indicators and any titration. Next we will see the complexometric titration application. What are the applications of the complexometric titration? Used for the determination of hardness of the water. Hardness of water हमें determine करना है by using the complexometric titration. Okay, example gold ions in ores. Then used in determination of metal ions, used in determination of uric acid ions, used in preparation of calcium assay, used in the determination of magnesium sulfate, used in determination of aluminum glycinate. Okay, glycinate. Okay, so these are the application, different application. ये हमें 2 मार्क के लिए क्वेश्चन आ सकता है मे बी. ओके, what are the applications of the complexometric titration? सिंपल है, हमें hardness of water, then determination of metal, different metal, calcium assay, magnesium sulfate, etc. Okay, so this is the simple way to understand the complexometric titration. What are the examples of that, what are the types of that, then application, disadvantages, definition, what is the chealating agent, what is the demasking agent, masking agent, then what is the meaning of ligands, etc. So आप ये एक बार देख लीजिए, पूरा वीडियो आप देख लीजिए प्रॉपरली. उसके बाद हम यहाँ पे आपको अंडरस्टैंड हो जाएगा प्रॉपरली. सो इफ़ आपके कुछ कमेंट सेक्शन में आप कमेंट करना चाहते हैं, कुछ इश्यूज़ है इस चैप्टर रिगार्डिंग, यू कैन आस्क मी, ओके, इन कमेंट बॉक्स. And kindly subscribe YouTube channel for the further more notifications of the different videos. Okay, thank you students, thank you very much for attending this session. Thank you very much.